Welcome to Ingenious Films, sharing the genius of engineering. What do you want to be when you grow up?
Either a scientist or a train driver.
A scientist. I would like to be an architect or a vet.
A vet. I want to be a vet.
I want to be a nurse.
I want to be a Navy doctor.
But vets, nurses and doctors all need technology developed by engineers. And here's one of them.
I'm Lindsey and I'm a bioengineer. I was a mechanical engineer as an undergraduate, and then I started to work in industry and realised that I wanted an application where I was helping people. So that's why I made the transition to bioengineering. I was always fascinated with how things worked and an application and an end goal. And I was always a little bit creeped out by gore, so I didn't want to do medicine, but I wanted an application to science, and that's why I chose engineering. I love the way that you can learn things at school and then you can apply things to real life, so you can see everything around you has had an engineer's influence. So everything works because an engineer has produced it and calculated it. The project that I work on is looking at blood vessel development in tissue engineered skin. So if you have a burn and it is extensive, what people can do in this lab, they can take a biopsy from you, a little small skin sample, grow up the cells in the lab, put it onto a carrier and transfer it to the injured part of the wound. But most cases it fails because blood vessels don't grow into the skin quick enough. So my job is to look at how we get blood vessels to grow into the skin so that we can help people who really need it. Blood vessels grow and are influenced by blood flow. So there you've got a fluid force going through a blood vessel. And depending on how fast the blood goes, depends on if the blood vessels sprout or not. So my job is to look at how fast shall we make that blood go, and shall we increase any other forces in the blood vessel to get the blood vessels to sprout. If you can understand how blood vessels grow, you can have more of an application, not just tissue engineering, but say cancer. So a cancer develops because blood vessels grow towards it and feed the cancer. So if you can stop those blood vessels from growing, you stop the cancer from developing and spreading throughout your body. So not only has it got applications where in tissue engineering we want blood vessels to grow, but in cancer we want blood vessels to stop growing. So to have this model where you can understand lots of things would help a lot of applications. In the future, we'd like to have a model where you can use the computer to predict what is going to happen, because that would stop a lot of the experimentation and the costs. So you could sit on a computer and put a factor in and another factor and then see what the outcome is. That is the ultimate goal, but I think it's quite complicated and it's a lot of years off at the moment. If you're at school now and you want to go into tissue engineering, it's a great time. So the industry is still quite young at the moment. There's a lot of research in tissue engineering, and you could go into all sorts of things: bone regeneration, nerve regeneration, cornea, looking at how to replace blindness, for instance. So there's a lot of different opportunities for people from all different backgrounds in tissue engineering, from chemists, biologists, mechanical engineers, biological engineers, like all sorts of backgrounds. It's such a good application of engineering, but it's something that's just recent, really. You know, it's just starting to come about and people are becoming more and more aware of it. So I think in time, we'll get a lot more engineers.